All right, we kind of started up with inequalities yesterday, and today we're going to continue with inequalities. Section 2 is all about solving inequalities and checking solutions to those inequalities. And you'll see that there's a lot of similarities between checking and solving inequalities as there is to checking and solving for equations. Okay, our steps that we're going to go through. Number 1, solve the inequality as you would solve a corresponding equation. So you're going to treat it just like an equation, go through the same kind of steps as we would when we would solve a normal equation. All right. When I say corresponding equation, basically all you do is you imagine that the inequality symbol is an equal sign and you solve it kind of the same way. Okay, so if we got y minus 10 is greater than or equal to 15, all right, the corresponding equation for that would be y minus 10 equals 15, and then you solve it very similarly, and then at the end just put that inequality symbol in and you're good to go. All right, the last step here is graph the solution using a number line. So once we actually get down to solving for y or for x or whatever variable we use it, we just graph the solution on a number line like we've been practicing. Okay, take a look at a couple examples. Letter A, solve the inequality and graph the inequality. N plus 6 is greater than or equal to a negative 2. Now, if this were an equation, we would rewrite this as just n plus 6 equals a negative 2. And to solve that equation, we would just subtract 6. Subtract 6. N is then equal to negative 2 minus 6. $2 in the whole, we subtract 6, and we're at negative 8. Okay? And since at the beginning we were dealing with greater than or equal to, our solution to this is just n is greater than or equal to a negative 8. Alright, so we've solved the inequality. We've got our answer here. N is greater than or equal to a negative 8. This is all values of n that are greater than or equal to negative 8. Notice that in this case, it's different than an equation where we've got multiple solutions to this because there are multiple numbers that are greater than or equal to negative 8. Alright, the last step here says to graph it. Again, we can do this really simple 3-part graph where we plot 0, our number, or negative 8, and the positive version, or the opposite, and a positive 8. This is all values of n that are greater than or equal to negative 8. So we've got a closed circle on negative 8 since it's greater than or equal to. Alright, and since it is all that are greater, our sign is just going to go this way. Okay, so this is our graph, this is our solution. If we wanted to check, again, we can pick any number between negative 8s that is greater than, okay, I think it's easy to kind of pick 0, all right? In our case, if we pick 0, 0 plus 6, is that greater than or equal to negative 2? Yes, it is, so we know we've got this one correct, okay? So this is our solution, this is our graph, and this is our check. Okay, some of these are a little bit easier. You may not need to even check. Okay, P or B, negative 5 is less than or equal to P plus 8. Okay, negative 5 is greater than or is less than or equal to P plus 8. We're going to extend this page, slide it down a little bit. Okay, so again, we solve it just like a normal equation. If we imagine this was an equal sign, we would say, all right, P plus 8. We need to subtract 8. Subtract 8. Rewrite negative 5 minus 8 is a negative 13 is less than or equal to P. Okay? Or if you wanted to flip-flop these, we could say P is greater than or equal to negative 13. I think this is a little bit cleaner. It's up to you. Okay? Our graph, again, a 3-part or a quick and easy graph to do. We plot 0, we plot negative 13, we plot a positive 13. Since P is greater than or equal to, we're going to have a closed dot on that value. All values that are greater going this way. Okay. Again, you can check it, plug 0 in. 0 plus 8 is 8. 8 is greater than or equal to negative 5, so we know we've got our answer correct. Okay. A couple more examples, we'll just practice. Solve and check each inequality, graph the solutions. Negative 4 plus a is less than 12. All right, again, solve it just like a normal equation. We add 4, and rewrite. Negative 4 plus 4, these are canceled. We've just got a is less than 12 plus 4, or 16. So this is our solution and our graph. Really quick. 1, 2, 3 points. We can plot 0, negative 16, positive 16. This is all values of a that are less than 16. All values of a that are less than tells us we've got an open dot and we're going to the left, less than. Okay, again, you can check each one of these by plugging 0 in for the equation, see if it still holds. All right, negative 4 plus 0, negative 4 is less than 12, so we're in good shape. Okay, last one. 3/4 plus a is less than or equal to 9 over 4. That is, believe it or not, a 9. 9 over 4. Okay, so again, same process. We're dealing with fractions on this one, so it's a little bit different. All right, but our steps are the same. We're going to subtract 3/4 from both sides and subtract 3/4. Ignore the phone. A is then greater than or equal, or less than or equal to, 9/4 minus 3/4 gets us to 6 over 4. Okay, or roughly a is less than or equal to about 1.5. Okay. Graph. Again, we're getting pretty good at this. 0, 1.5, negative 1.5. Alright, and these continue on. A is less than or equal to 1.5. We have a closed dot on 1.5, and we're going this way. Okay. So again, treat it like an equation. Okay, we get pretty good at solving these equations. The inequality just adds a little bit of wrinkle. There's multiple solutions to these. All right. Last one, kind of applied to a real life situation. Mr. Neubauer's goal is to do at least 48 crunches every single day. At noon, he has already done 3,500 crunches. Write and solve an inequality to find the possible number of crunches he can do to reach his goal. Okay, so we're going to say my goal is going to be my current amount plus the remainder. All right, and it says that I want to do at least 4,800. Okay, at least. This amount has to be less than or greater than or equal to 4,800 crunches. All right, so our current amount, we know that so far I've already done 3,500. 3,500 crunches, and we're going to add the remainder to that. Let's just call that R. It's got to be greater than or equal to 4,800 crunches. All right. And from there, again, you solve this. You subtract 3,500 from both sides, and we get R has got to be greater than or equal to 4,800 minus 3,500. That gets us to 1,300 crunches remaining. All right, now notice R can be greater than that. I can do more than 1,300 if I'm, feeling like I'm up to it. I can do more. If not, we can be equal to 1,300. Okay. Talked about this more in class. Have a good night.